Welcome! This video will aid in your understanding of gas stripping in a packed column experiment as performed by Charles Neal, John Showalter, Delmar Milbury, and Lori White. Packed columns are used for absorption and stripping. This column will look at the stripping of dissolved ammonia in water using air as the gas. This video shows a simplified layout of components used in the experiment. An important part of this experiment is to analyze conditions that affect flooding of the column. Flooding occurs when the gas velocity is too high and prevents the liquid from flowing down the column. The objectives of this experiment are to determine the column's ability to strip ammonia from liquid to gas and determine the flooding velocity of the column. Some applications for using a packed column include distillation, gas absorption, liquid-liquid extraction, and stripping. Before beginning any experiment, it is important to determine the safety hazards. One safety hazard is the inhalation hazard due to any ammonia gas released into the room. To prevent this, ensure that the exit gas is leaving through the fume hood. Another hazard arises from the pressurized fluid, creating a pressure hazard. To prevent this, ensure that there is a path for the fluid to flow while the pumps are operating. There could also be a slip or trip hazard if any liquid spills. Be sure to clean up any spills immediately. A sharps hazard could arise when working with glassware. Be sure to carefully handle glassware and correctly clean up glassware when applicable. Equipment and chemicals needed for this experiment include a liquid mixture of water and ammonia, a large tank to store this mixture, forced airflow needed for stripping, a packed column to perform the stripping, and liquid and air tube flow meters to monitor the flow rates. Sampling and equipment chemicals include Orion ammonia ion selective probe to measure the concentration of ammonia in the liquid, an ammonia sensor to measure the concentration of ammonia in the exit gas, 50 milliliter beakers to put the liquid in for testing, and 1,000 milliliter beakers to drain the liquid in the pipes to prevent false flooding conditions. Before beginning this experiment, make sure that the column outlet gas tubing is securely inside the fume hood to prevent inhalation hazard, and open the gas and liquid side valves before starting the compressor to prevent damage to the system. Turn the air blower on, increasing the flow rate to 2 cubic feet per minute through the column by using the valve on the air side flow meter for fine adjustments and using the valve near the blower that exhausts to atmosphere for coarse adjustments. Increase the liquid flow to 0.05 gallons per minute by using the valve on the liquid flow meter for fine adjustments and adjusting the valve on the recirculation line for coarse adjustments. Wait 20 minutes until the column has reached steady state. During this time, monitor the flow rates to ensure that there are no changes in the gas or liquid flow rates. Once steady state has been reached, measure the exit gas concentration of ammonia with the ammonia sensor. Collect 2 liquid inlet and outlet samples from the column. The inlet sample is taken from the top and the outlet is taken from the bottom. Add 1 milliliter of 1 normal sodium hydroxide to 25 milliliters of the 4 liquid samples. Add a magnetic stir bar to the mixture and place on the magnetic plate. Carefully place the ammonia ion selective probe in the sample, ensuring to be careful with the tip of the probe. Record the concentration of ammonia provided by the Orion system. Repeat for all 4 samples. Increase the liquid flow rate to 0.1 gallons per minute. Slowly increase the gas flow rate while ensuring the liquid flow rate remains constant. Look for bubbles in the bottom of the column. Once you can see bubbles, record this gas velocity. This is the flooding velocity. Thank you for watching this video on gas stripping in a packed column.